a woman says she won the jackpot in the lottery on a Friday and then in the Saturday lotto. In the lottery, i.e. the Friday one, she has to choose 3 numbers from 1 to 10 and 2 lucky stars from 1 to 5. And in the lotto, the Saturday one, she just has to choose 4 numbers from the numbers 1 to 12. What is the probability of winning both lotteries, B, neither lottery, and exactly one of the lotteries? And we're going to actually comment on each of these. So in order to work out the probability of winning, we first have to look at the number of ways of choosing the numbers in each lottery. So for the Friday lottery, which we're going to let be F, so what does she have to do in the Friday lottery? She has to choose 3 numbers from the 1 to 10. So that is 10C3, 3 numbers from 10. And also we have to choose another 2 from 1 to 5. So we have to multiply. These will be mutually exclusive events. This event does not, independent events. This event does not affect this event. These are independent events. 2 numbers from 5. And that comes to 120 times 10, which is 1,200. For the Saturday lottery, which we're now going to call S, she just has to choose 4 numbers from the numbers 1 to 12. So that's going to be 12C4, 4 numbers from 12, which gives me 495. So the probability of winning the Friday lottery is going to be 1 out of 1,200. The probability of not winning is going to be 1 minus 1 over 1,200, which gives me 1,199 out of 1,200. And then the probability of winning the Saturday lottery is 1 over 495. And the probability of not winning the Saturday lottery is going to be 1 minus 1 over 495, which is 494 over 495. Right, we're interested in winning the Friday and the Saturday lottery. So if we draw a tree diagram, so first consider the Friday lottery. She can either win it, which is 1 out of 1,200, or lose it, which is 1,199 out of 1,200. Right, if she wins the first one, on the Saturday she can either win the Saturday one, or which is 1 out of 495, or not win the Saturday one, which is 494 out of 495. The probability of winning not winning the Friday, the probability of winning the Saturday is still 1 out of 1 over 495, and the probability of not winning is 494 divided by 495. Right, we can work out the probabilities by multiplying. So if the probability of winning both is going to be 1 times 1,200 times 1 over 495, which is 1 out of 594,000. The probability of winning the Friday but not winning the Saturday is going to be 1 out of 1,200 times 494 out of 495, which gives me 494 out of 594,000. The probability of not winning the Friday but winning the Saturday is going to be 1,199 out of 1,200 times 1 out of 495, which gives me 1,199 out over 594,000. And the probability of not winning either of the lotteries is going to be 1,199 out of 1,200 times 494 out of 495, which gives me 592,306 out of 594,000. Right, these are independent events. Okay, you multiply them. These are mutually exclusive events. If one happens, and the most likely one to happen will be that, okay, the other 3 events cannot happen. That's why they're called mutually exclusive. One event excludes the other event. These are the 4 different outcomes that can happen. So just quickly redrawing the tree diagram again and now answering the questions. The probability of winning both lotteries, you get that from this one here. So that's going to be the probability of F and S which we've already worked out to be 1 out of 594,000, and that is as a decimal 0.000001968. It's very unlikely. The probability of winning neither lottery, well, that's going to be this one here, and we already worked that out to be, that's probability of not F and not S, which is going to be 592,306 divided by 594,000, which we work that as a decimal at 0.997. This is the most likely thing to happen in this experiment, and the probability of winning at exactly 1 we get from that one and that one. These are mutually exclusive events, so we have to add them together. So the probability of F and not S plus the probability of not F and S, that's 494 out of 594,000 plus 1,199 over 594,000. If we add those together, we get 1693 over 59400, which as a decimal is 0.00285. That's also very unlikely to happen. Basically, it is not very likely for anybody to win the lottery. In the real lottery, obviously, there's a lot more numbers to choose from. But I hope you understand. And so this example, and I thank you very much for watching.